Okay, in this video, let's have some fun. I've got several instances where I've got two LED bar graphs set up, and it takes up quite a bit of space on the breadboard. Plus, I've got all the different resistors that are needed to limit the current going through these LEDs so that they don't burn out. And I want to replace these with something that is a little bit more custom built for my needs. I usually need 16 of these. I've got 20 sitting here. I've got extra of these LED lights that I've ordered, and of course I've got extra of the resistors that I use to limit the current on the PCBs. I figure I could likely put those onto a little mini circuit board here that I could use to create my LED displays of contents of registers and the like, bus contents and what have you. And then I would be able to use the blue LEDs and the red LEDs in order to light up my breadboards. Like I said, let's have some fun. Let's get into that. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. I'm going to start with a fresh KiCad project here, and I'm going to get into the schematic and start laying this out here. Well, I've got this huge page set up, but that should be okay. The first thing I want to do is I want to drop in a series of LEDs here. And let's just zoom in. Now, I'm going to orient the LED this direction. And the reason I'm going to orient it this direction is there is a positive side and a negative side of an LED. And I can't ever keep them straight. Because I can't ever keep them straight, what I'm going to do is orient this bar here, which to me represents ground. I may or may not be describing that right, but it helps me understand that that is the more negative side of the LED. At the same time, I'm going to go grab a resistor and drop it in right underneath that, make that connection. Now the values of these don't really matter, and what I'm doing here is simply trying to lay out all of my components here. So that would be a 4 LED, there's 8 LEDs, and then of course if I double that again, there's all 16 LEDs. Now on either side of this, I need pins. I need a 1x16 pin. I need to flip that. Well, let's drop it in here first, and then I'll flip it. Need to flip that vertically. Get rid of all those lines there. So that should give me all the connections that I need. I'm going to just eliminate all of the markings here just because this is so relatively simple that I don't really need them. Let's decorate those with annotations. Let's run the electrical rules check, which I expect nothing to pop on that. And now we get into footprints. My LEDs are surface mount 1206, and I'm going to go with the 1206 hand solder footprint. Of course, I didn't actually assign that, did I? LED SMDs 1206 hand solder. Okay, so all of those are assigned. My two connectors, 2.54 millimeter pitch. These are the pin headers. I need 1x16. Pin one left, pin one right. I don't know that that matters. So, and I did it again. Bloody brilliant today. And then my resistors are all 1206 as well. And I believe this is the hand solder one, yes. And so that should give me all of the footprints that I need. So now if I get into the PCB layout and do the import, here's where things kind of get a little interesting, because put that on the back. Let me make sure here my grid is set right. Now I am not going to put the fab indicators and the what's what indicator on there. It should be relatively easy to figure out based on how things are lining up here. Okay, so that's 0, that's 1 or 0.1 inch, 0.2 inch, 0.3 inches. Now the LED graphs that I'm using now, those are the width of them, but if I take one of these diodes, you can see that it actually does not fit in between the two rails. I believe I can get 805s in there, but I'm going to use the supplies that I have already. So that means I've actually got to move this down one so that I can center this up in between. Yeah, I don't want that to be there. I don't want that to be there. I don't want that, or frankly that. Because the diode, the fact that it's a diode on the top doesn't really matter. The markings really don't matter to me so much. All right, so there's a bunch. Rotate those. I'll drop those in place. Now the challenge is cleaning up all of these little markings here. Whoops. And then I've got to get them aligned. All right, so now I've got 7, 8, 9, 10, 11, and 12. I bet you if I hide that and that, adhesive and paste. Now I want to keep the silk screen and mask. All right, so these are all nicely centered. And now I need to get the resistors. And these need to be placed on the back and then rotated. And so I'm going to stick them here for the moment because I ultimately end up needing to do the same thing. Now, keep in mind the values of these resistors are really not going to matter as far as the PCB is concerned. But in reality, I'm probably going to use all 1K resistors. And that's only because I've found that the 220 ohm resistors leave the LEDs just a little bit too bright for the camera. All right, there we go. And so now these should be able to be drug up and dropped up here. I need to rotate each one individually. No, I don't. Okay, so now I have some number of connections that I've got to create here. And so we can go from the more positive side to the LED. On the bottom layer, we can go from the resistor to the more negative input. And I guess the question I have is, what is the trace width here? And what does it need to be? Okay, I just went and double checked, and my minimum clearances here are 0.127, so I need to update my traces. Actually, let's just make them 0.13. In this case, it really doesn't matter because I've got plenty of room on the board. If I redraw that, 0.13, so I should really just start over. Global deletions, tracks and vias, all layers. All right. So again, this is the more positive side from the more positive pin coming into the LEDs. And then if I go to the back side, this is the more negative off the resistor. And then finally, I need to connect the cathode side of the LED to the other side of the resistor. Okay. 0 unrouted. So that should then take care of everything. If I look at this in a 3D, you can see the LEDs up there on top, the resistors there on the bottom. The only thing I want to do is on the front silk screen, I want to put a plus up there. And a minus there. And get down to a smaller save that, run the design rules check, make sure everything's going to work out okay. I have one problem. I have no edges. So let's get the edge cuts. So for the edge cuts, I need to place a rectangle. Rerun them, no problems. So I've got the marking here that tells me that's more positive and more negative. I could put a marking on there for the color LEDs that I'm going to put in, but it's just as easy to plug it into a breadboard and take a look at them. But that should make my breadboards look a little bit better. Okay, the next step here is to export the Gerbers, which are needed for actually building this thing. So let's plot those. Okay, that should take care of all of that. So if I look here and I open up the viewer, this is the copper layer. I'm looking at the bottom here, the bottom copper layer. Bottom solder mask. That's the paste layer. On the bottom silk screen. I did not want any of these on there, so I need to update and regenerate that. Let's uncheck that. My bottom silk screen, that looks better. Edge cuts, that's real simple. The front copper, front mask, front silk screen. There's the plus, there's the minus, and then there's for each of the LEDs. Perfect. Non-plated through-hole drill map, nothing. Non-plated through-hole drill, nothing. Plated through-hole drill file. My vias, and then for my pins. 1 millimeters and 0.4 millimeters. That's perfect. I'm quite pleased with that. That looks really good to me. And so I'm going to close this. There's two more sizes I want to create. I want to create an 8 LED size and I want to create a 4 LED size. So I will do those as copies and prune down the things that I don't need. You'll get to see that kind of on a fast forward. The final thing I want to work on today is this switch. And I need to change my timer, and in order to do that I actually need to change the type of switch that I use for my single step. What I've got is a single pole, single throw momentary push button, which means that normally the contacts are open, not conducting electricity. I push it, it releases. When I release, it goes back to its normally open position, but while I've got it pushed, it's closed. What I need to switch to is a single pole double throw switch. So I've got a normally open position, and I believe this is the normally open here in the middle. Yes, a normally open position, so that in this position, this contact compared to common is open. It doesn't conduct electricity. But I've also got a normally closed pin, so that in this position, these two are conducting electricity. And so when I push the button down, these two pins will conduct, these two will not, and then release. So this is a single pole, meaning there's only one contact that wraps around a pivot point. I guess that's one way to look at it. It may not be the right way to look at it. But double throw, meaning it's got two contacts. And this won't fit into a breadboard. You can see it's got normally what you'd slide connectors onto, and I need to convert this so that it will fit into a breadboard so I can use it for my testing. And so for that I want to design a small PCB for that, which holds 3 pins. And the problem is there's no footprint for this thing, so I actually have to create the footprint for it. Now, this is the data sheet for this particular switch. And there's a couple of things that it notes in here. All of these measurements are in millimeters. So for example, the width of one of the pins, slots, tabs here is 0.6 millimeters. And I have a distance between the common and the normally open pin. And I have a distance between the normally open and the normally closed pin. What I don't have is an offset from the beginning or the end of this. And so I've got a caliper out here and trying to get some measurements of that. So the easiest way to do that is to set this here, and then there's a little pin that extends to measure distance here. And so I set it there, square it up. Okay, that's 1.8 millimeter on that side and 1.9 millimeter on that side. And this is not quite centered, but I think I can make use of that. Just assume that it's centered and go on from there. The other one I want to double check is this distance here. And so this is the wide 2. I should have 9 millimeters plus 0.6 millimeters, then I come up with 9.55. So that's actually pretty close. And if I come down here, I should have 6.9 plus 0.6, so 7.5 millimeters. And I did actually rack that pulling away, but 7.45, that's reasonably close as well. The overall distance here is 20 millimeters. That's dead on. And then I see a 6.5 millimeter distance or width up here, 6.5. So it's reasonable. 3.4 millimeter width here on the connector tab, 3.35. That's reasonable as well. I'd rather have it smaller than wider, because if I use these dimensions, I just can fill it with solder, because it'll end up being a plated through hole. With that, I think we can go ahead and use those numbers up there, and let's see if we can make a footprint. Okay, this ought to be fun. Let's see what we can do, because this is the first footprint I've ever made from scratch. Let's start with a new footprint, and I'm going to name it after this micro switch. Make sure it's a through hole, because I've got slots I've got to get through. So I'm going to have this be the center of my component. And let's start with the center pin. Well, the center spade. It's a through hole. This is going to be pad number 3. And its position in millimeters should be 0.75 plus 0.3. 0.3 being half the thickness of the spade. So 1.05. I've got a little drawing here that I'm using to try to reference. It is going to be rectangular. Pad size. Let's make that 1 millimeter wide. And then 3.4. Let's make that 4 millimeters tall. I'm just looking right now about how I want this pad to look. All right, let's take a copy of that. I need that to be 0.75 plus 0.6 plus 6.3 plus 0.3, 7.95. 8.4 plus 0.3 is 8.7. That's going to be 1, that's the common, minus 8.7. Okay, so that hopefully gives me what I need. And then on the front silk screen, I'm going to place a rectangle. Starting point should be minus 10, and it's minus 3.25. The ending point should be 10 and 3.25. So that should give me the footprint. Let's make that a little bit easier to move. That should be on the fab layer. That hopefully, and I don't know for sure, but hopefully gives me what I need in order to do this. Now, my challenge is that the holes or these spades are not rounded, they are rectangular. So let's change that. So the hole shape it has to be oval, so that means I have to extend it. It's oval, which means I've got half a circle on each end. The radius of that circle is 0.4 millimeters. If I take 0.4 millimeters off of each end of the slot, I end up with removing 0.8 millimeters. That's 2.8 millimeters long. That's too short. So I really need to add 3.4 plus 0.8. So that's going to be 4.2 millimeters long. Gives me a little bit bigger of a pad. That's almost, well, half of a millimeter on either side. That should be plenty to get it to set. So that is 1.2.6 of a millimeter. That's the same width as the spade. I think I like that better. As a matter of fact, I think I want to add another millimeter to that. Okay, that's a little bit too big. It's still a little bit too big. And then 5.5. I think I'm okay on the ends over here. So let me make some notes here. 0.8, 4.2, 2.3, and 5.5. And you make the other ones look exactly the same. It's going to be a lot of metal to warm up, but I think that's going to give me a good connection. Just double check my pin numbers here. 1 and 3 and 2. Perfect. Okay, one quick correction here. I did go back and double check my math to make sure that my pin spacing or my spade spacing on center was accurate, and this was not. So I did have to back this up 3/4 of a millimeter, and that was because the 3/4 of a millimeter I added in here, I did not properly subtract that when I calculated the position of spade 1 or pin 1. So I made that correction, and these two spades seem to be set back equidistant from the edge, with this one maybe just a hair farther or farther in, and I'm okay with that because I believe I've got the tolerance I need to get that soldered in properly. I didn't want that correction to be missed. I believe it was on this. I also had a typo here, which I found it while I was editing, and I did correct that. Okay, so I've created a project in KiCad for the little switch PCB. So let me go ahead and get the schematic drawn up, and then I'll make the PCB. This is more of the same, so we'll rush through this. Okay, I think that's everything. Let me add that to my cart and come back and wrap up. That's going to wrap up the smaller PCBs that I want to get on order. I have two additional designs that I need to pull together. One is for the fetch register. It's going to be largely a copy of the actual register itself, but the PCB is going to end up being a little bit more involved because I can't just cut components off of it and shrink the size of it. The second is going to be somewhat of a backplane where I have the ability to hook 6 of my register PCBs together and then have interconnects on the top and bottom of that. And that should hopefully allow me to expand out very quickly and without having to order a massive backplane, not knowing where everything is going to go. So this will give me kind of an interim backplane, allowing me to take care of hooking up all the registers together. And then finally, I said 2, but I'm going to name a third. I may end up creating a couple additional PCBs for hooking those backplane components together. The goal here is to make this order as large as possible. Thank you. We'll see you soon.